Hey everyone, welcome back to my channel Deep Code Vision. Today we will be continuing with our data types uh, videos. So we are talking about built-in data types at the moment. User-defined data types will be discussed later. So we completed till strings in the part 1. If you haven't seen my part 1 of the video, please uh, there will be a link in the description, or you can press the I button. Also, so let's jump in. So bytes can be thought of a group of byte numbers. Now, what are byte numbers? These are positive integers between the range of 0 to 255. So any positive integer between 0 to 255, and any number of positive integers can be stored. So one of the easier way to uh, assign a byte or bytes data type is to first declare a list. So we will be talking about list in details in this video, and I'll probably make another separate video on list because it's quite an extensive topic actually. So for now, let's see how you can define a list. You might be familiar with it. It's a square bracket, two square brackets, and values separated by a comma. So let's say we have a list of these positive numbers. Now you can only write from 0 to 255. Now to change it, if I print the type, it will probably say, the list. So that's a list, right? Hopefully you can see. Now to change a data type from one other data type, we have done it a couple of times in the first video. We just call the method. So byte num becomes bytes and byte. Now if I understand what it is, so you cannot directly print the whole byte or uh, bytes data type. So what we need to do is we need to comprehend or extract, as I like to call it, extract the numbers from the bytes or byte variable. So for that you can just write for num in byte num print, and let's comment it out because that is not what we need. Now we can see that it will print each of the. So this is how byte data type is. You cannot print directly the elements inside of a byte data type, or a byte variable rather. Another thing you cannot do is what we call, so sequences are differentiated on the basis of whether it is mutable or immutable. Mutable or immutable means that you can change a value, or you can add values to that sequence of values. So that means it is mutable. What I mean by that is, string we called, if you go to my last video or here, uh, we we could change the string values, and like we can call the index, let's say I call string this index and add and we can change this into another character, but that cannot be done in here. So that um, that is defined as the immutable part, where bytes are immutable. Now let's say oh, let's try to do that. Byte num 0, the first value I want to change it to 45. Now if I run this, it will throw me an error. So that does not bytes object, so this is an object. Bytes does not support item assignment, so you cannot individually assign items to byte or change the values of the elements. You now if I do this, it will print out the 13, which is the first element. Now you can print out using indexes, so you can do that, but um, you cannot mute, or you cannot change the values as such, or you cannot add values at the last, like you can do with other sequences. So that's how bytes are. Now another data type which is very similar to bytes are byte arrays. Now byte arrays, you can do assignments, that's the major difference. So let's see how you can call a byte array. So on that same list, which is my byte list variable, I call byte array method, and if I print the type, will show the class as byte array. Now let's say okay, let's try to assign a or use the assignment operator. uh, Byte arr, let's say I want to assign the second or the third element to 52, and it will let me do that. It does let me do that, and it runs without an error. Now if I want to print again, you cannot just print byte arrays as it is. You have to use a for loop and extract the, so let's say num byte print. So that's how you, and you can see that the value on the 0 1 2, so that's the third element, value has changed to 52. So that's how you use an bytes and a byte array data type. Now these are mostly used to save array values, for positive integers. However, in quite rare occasions you will find the use of bytes and bytes array data type. It is used, but it is very rarely used. It's better to use a list and better to use tuples and all those things. So let's see what those are. Now similar to as we have been converting data types from other data types, let us convert back the byte list from byte arrays, let's say. So uh, say byte list 1 is list byte which is my byte array. Now if I print the type, this is just to check whether we are correctly. Now it shows us the class as list. Let's not run the whole program, but we have a, so that we can run this part of the code itself and it will work the same thing. Now one thing that we can do is we can print the whole list without calling for, you can of course call those things. You can of course call those things for loops. You can call for loops and do that's perfectly fine, but you can call, like, you can print the list as a whole. The one thing that separates list from bytes and bytes array, apart from the things that we talked about just now, is that list can store any data types. Like it can store integers, floats, negative numbers, complex numbers, everything in one go, and that becomes quite helpful for us when we are trying to do some data science projects or anything, because if you imagine a data, you will find that it might contain uh, integers, strings for most part. It will contain some sort of floating points. It may contain complex numbers, like, so it becomes difficult for us to store. If there wasn't like list or sequences like that, it would be very difficult for us to store everything on under one hood. So uh, that's why lists are very extensively, like, I cannot stress enough how extensively list you will be using lists in your any kind of projects, data science, anything. So how we can store, let's say I have a number, I have a string, I have a floating point or float, I have another number which is a complex number for some reason, and yeah, another string, and that's perfectly fine with uh, Python, and it will print so let's say list for, just to make things fun, uh, so it prints everything in one go, and it's fine. Now lists are again mutable, so you can change the uh, list assignments or lists. How you can change, let's say I misprinted 10 plus 1j, it should be only 10, so that's the first index is 0, 1, 2 and third, so that's fourth number, so that's the third index. So I call list put v and I just write 10, and that is type. So that's that from one data type it gets changed into an integer data type. Now let's see what it returns for that. So it changes from that complex data type into an integer data type. So that lists are quite like versatile. It can do a lot of things. You can treat every part of the list as anything, like you can store list inside of a list, so that's called a nesting of lists. So you can do that. You can store tuples inside of a list. You can store byte arrays inside of a list. You can do like it's very versatile, and that's why it's so hugely used. I'm just barely scratching the surface in this particular video. I will make a separate video with all the list comprehensions, list methods, and uh, the versatility in general of using a list. You can do, of course, the things that we did with the strings. So you can call indexes, you can do slicing of index, like slicing of lists. You need to do the whole thing, so you can do that. So it shows you the first 0, 1 and 2 excluding the last index, as we did for strings. Again, please check out what I am talking about. Please check out the last video. You'll find it really helpful, I believe. So another thing, you can, of course, you can also do the negative indexing as we did with strings, and do this as well. So you can play with that and see how it works. Now you can do the like names in list put, and so this means I'm trying to index everything, and I write names, just like a variable for our. Now it shows everything and it runs for the whole part. You can index it as this, so it will run only the first, second and third, so 0, 1 and 2 index. So that's how it works. Okay. So next part is the immutable variation of list, if you want to call that. That's tuple. Now tuples can be pair, or it can be as big as a list. It can be any n number of elements inside of it. So although it will become difficult for you to handle such a big list, or like you of course want to optimize your codes, right? Optimize your problem statements. So that's why. So let's see how you can initialize a tuple. So we have the list foot, right? I'm gonna copy and paste it so that I don't have to type. So let's say foot or top foot. So for that I call the tuple method on the list foot. So now it becomes a tuple. So if I print the type of top foot, becomes a tuple. I'm just appreciating myself for the perfect variable names. Lovely. So you can of course do top foot 0. You can print a particular index or element in a particular index of tuple. You cannot change tuple values. So You can do slicing of the tuple, you can do everything as shown in here. So I'm just gonna write, you can do this, you can do negative indexing if you want, but you cannot change. If I try to change a value, if I write tough 0 to become 9, that ain't gonna happen. So it throws me an error, which is a type error. Tuple object does not support the item assignments. If you remember, we got the same error when we were doing the byte part. So these means these type of sequence data types are immutable. um, Next, let's talk about something which we will be uh, regularly using in our any type of projects, are called range data type. Now what is a range? Let's say I'll try to explain using a use case of range. Let's say you have uh, you are extracting a data from somewhere. Okay, now you don't know how many columns of data there are, so you hence you don't know what your length of your lists is. So here I know the length of my list is 1 2 3 4 5, so that's 0 1 2 3 4, so that's my list index, so I know that. Now suppose I had hundreds, you don't know how many, so that becomes quite difficult to extract each of the values like we did here in this particular scenario. It becomes quite difficult to exactly write this, or maybe uh, this part we don't want to write now, or we only want to extract a certain number of elements from that list. We don't want to extract everything. Now we can of course do that from the part we have selected. It's selected. Now there is a better way to do that, and I'll show you that. Or think of it as this way. Let's say we have two lists. Now we uh, from one list we come to know the number of elements. So let's say one list has 50, another list has 60, so I don't want the last 10 elements. So how do we extract the length of the first list from my second list? So let's see how. So that's the range data type we use. For that, let's say for our ease, let's do this so that we understand what we are doing. Now I want to know the length of the list, or length of we call the len method on the list. So this returns the length of the list. And now what we can do is we can we can for j in range, that's how you can specify the first argument as 0, or by default it will take 0. Let's do the specification as it is, length foot, and you can print the list foot with the j as their index. Now let's see what happens. So that it shows us each of the values. Now this will return the index. So 0, first loop will return 0, so it prints the 0th element, then it returns the first, the second, the third, and the fourth respectively. Now You can of course change a range into a list. So you just call, so if I range or ANG put, and then range of list comes list RNG. So that becomes a list with the range. Another thing, if you draw up the help or range, what it returns, or the document, so it returns quite a lot. So it says the starting, which by default it takes as 0. It asks for the stopping part, so that you can pass on as a len object anything you want. So it should be a object, so this is a range object, so it returns a range object. And it also asks, by default the step is 1, but you can specify the step. So if you, I'll show you how it's yeah. So you can do, let's say I just want to print, let's modify the this part a little bit. So let us modify the list a little bit, and let us, so I have modified my list. Okay, now you see that my list has names on all alternate indexes, right? So if I do this part again and I ask it to skip one, so steps to be 2, let's see what it returns. So it returns the jersey numbers or the numbers. Okay, now if I do this and run it, it returns the names. It returns the names. So that's how you know how to use the range part. Now that's about the range data type for now. I'll show you an application of range when we discuss the mapping data type or the dict data type, and we'll see how it goes. Now the next part is the sets. So sets, you can think of it as unique element finder, unique element generator. It basically is can be thought of as a sets in maths. It's similar, and there are two type of sets data type. One is a set data type, one is a frozen set. And frozen set is immutable and sets are mutable. So if um, I copy this and I copy this and paste it, so I just made two same thing, so there are double of each element, right? Now if I call set, so set foot, if I call set on list foot and print my set foot, it becomes so you see that it shows us only the unique elements. It shows only the unique elements. Now what else we can do? uh, we can we can add sets. Let's say I want to add set put. I call the update method, and I call a pass one thing, and that's number 8. And if I now print it, because 8 is not a unique, it's unique, it will okay. So if I need to pass on a list, yeah, so you see there is an 8, and if I want to pass another thing, let's say I want to pass like that, you see it becomes it has all the unique elements. Now you can of course remove in the same way. Dot remove, let's say I want to remove these two, no, or let's say I want to remove this. So if I print now, okay, sorry about that. So it removes the 7, and so while updating you can update it with a list, while removing you need to do one by one. So you can actually use set to find the unique, let's say I have a string and it says wrong. Okay, now if I set set if I do this, and so what it does, it uses the set to show all the unique alphabets. So so every alphabet here is has will have a separate index, so you can do that. Now similarly, frozen sets, there is nothing special about it. The frozen sets are immutable, so once you so update remove these methods won't work. So if I call a frozen set on frozen str set, cannot change. So if I try to change dot update, let's update e. Now if I run this, frozen set has no attribute, or you cannot call an attribute of update. Similarly you cannot remove, so that's immutable. Let me comment it. So that's how sets and frozen sets work. So if you look at what how we have discussed, we talked about bytes, which are immutable. We talked about byte arrays, which are mutable. We talked about strings, which are mutable. We talked about tuples, which are immutable. So it's similar, but one is a mutable, one is a immutable. Now it has their own place. Now um, where if you ask where mutable, of course if you are using a iterator or something, then you need to mutate everything or mutate, so it should have a mutable attribute. Now immutable is somewhere you don't want to change certain checkpoints. Like if you have checks, let's say I have this part, like use case, if you say you can, let's say you are splitting a word document, okay, and you want to check whether these keywords are there. So there you might be better off using a tuple, because you don't want to um, mute, like you don't want to change that, because you are searching for keywords inside of a let's say you are using a review like Amazon product review. You are trying to split, you have extracted the review, you want to use like sentiment detection, whether it is a positive or a negative. So if you have a positive sentiment words, so you use that in a tuple, you save it in a tuple, and then you can check whether those words are there, and if it has those words, then probably it's a positive review, and vice versa for negative reviews as well. So everything has their own use cases. That's why there are so complementary data types. So one is mutable, one is immutable. So that's about it. Now the last built-in data types that we are going to discuss here is a dictionary or a map. So what is a map? If you think about a real life map, or what is a map, so essentially you are using something like, let's say, think of it as a matching. If you English or anywhere you have done matching, so let's say boy has a name John, and girl has a name Jane. So if the boy maps to John, or vice versa, John will be mapping to a boy and Jane will be mapping to a girl. So that's essentially what a map is. You are trying to use two, so there are two sets of elements. One is called the key of the map, one is called the value of the map. So using the key you can search for the value or values. You will find it later that you can use number of values. So one key can correspond to a number, a list of values. Actually what I'm trying to say is, so um, so let's say boy, the name of the boy can be John, David, and all those things. Now let's see how we can assign a dictionary, or call create a dictionary of values. Let's see. So let me write, actually, yeah, so let me call a list. So I initialized a list with jersey numbers and names corresponding, player names corresponding to that jersey number. Now how we can initialize a list, an empty list. Let me initialize. That's how you initialize an empty list. Now remember, we this is one way. It's a pretty cool way of initializing keys and values in a list. So if you if you remember, that we talked about using range, and we can start, stop, and the steps we can initialize, or we can pass those arguments. So let's do that, and using a for loop, and I can range, I can do the dictionary thing of rm. So I'm alternating, so 0, so this this, and I sorry, I don't want to print it, I want to store it in my rmd. And this is how you specify a particular key. So that's rmi, this is the key, and the next part is the value, so I plus. So you can use a operator inside of a indexing as well. So that's pretty. So if I print this now, the dictionary, let's see. So you see that the dictionaries, the key values will be keys and values will be separated by a colon. So this is the key and this is the value, this is the key and this is the value. Alternatively, you could have just used the names as the keys and that as the values. So depending upon your problem statement, you can be doing that. So now this particular use case I have used, like I have deliberately done that player names and player jersey numbers are at alternate intervals. So you might not be doing that in real life or real data. um, uh, you can use pre-processing, like you have to use some pre-processing step to make it in this format so that you can do the dictionary part. You can see a particular, use a particular key to print particular value. So 8 is corresponding to kaka, so you see that that is if you print the type rm, shows you that the class is dict. If you just want to print the keys of a particular dictionary, so that you can essentially, what you can do is you can, I'll show you. Now it shows you that is dict keys. Now what you can do is you can call list on this and you can print. So now you see that these are the list of keys that that particular dictionary has. Similarly, you can print, you can store this list for your further use later. Like you might be let's say you have another team, and you can use those jersey numbers to compare everything. So that's how you can do go about doing things in dictionaries. Now let's say I want to list of the values inside, so I just write values. So this is the attribute. This is what we call an attribute. Don't worry about it right now. You'll we will go into for a lot details later. So you can extract as a list. If you only wrote rmdict.values attribute called the values attribute, it would have returned as an object of values. And now here it changes itself into a list. So that's pretty cool, right? Uh, of course, list dictionary values are mutable actually. So if I use dict, let's say I want to change Raul. I want to change the jersey numbers first. And now RM take to 10. So I am switching Benzema into the 10 from 10 jersey number to 9 jersey number. Let's say Raul left the club. And so now uh, I have a space on jersey number 10. I don't have anyone in jersey number 10. So if I so I have Benzema in both the places, right, for jersey number 9 and jersey number 10. Now I want to add another player inside of jersey number 10. So what I would do is I call the value and I pass on the name of the player. Now if I okay, it should be capital M. Yeah. Now if I print the rm dict, see that it shows Modric and the just 10 key value. The value of 10 key is Modric, and the Benzema has shifted to the key 9. So that's how you can use dictionaries to map certain keys to values. Um, Now a real life use case I can think of is, let's say you have 100 patients and every patient has a has a hemoglobin level and a blood sugar level. So you have two values and the key is your patient number. So what you can do is you can use your patient number as your key and have both the values. So that's how that is how you pass two list, like two values as for a particular key. And we will get that a lot when in solving real life problems. Now when I talk about dictionary in more, so a complete video on dictionary should be made so that the versatility of dictionary can be brought through. Just like list, dictionaries are most probably the second most used, or if not even higher used um, data type in any data science project. Now you can of course delete a dictionary key value pair. Let's say I want to delete this. Now it deletes both the key and the value. Yeah. Now one thing, another data type which is a special data type, I should have mentioned it in the first video itself. It's called a none data type. So this is similar to null if you have used any um, other programming languages like Java. So it's the same thing. It doesn't uh, mean much. It is a placeholder of sorts. Sometimes some functions will return none. It will perform the function but it will return nothing. a void or null. So that's none data type in Python, so you can use it as a placeholder of sorts. Like if I say a none equals to none and I print the type, say what type of a what type a is, so it's a none type data type. um Now if I say I in range 10 and I use a dot let's equals to I plus 1, so the last value doesn't mean much, this code, but you can see that you can initialize a non type. Now where it is mostly used, it can be used in at least where I have used in my personal experience is when we are when I am doing a deep learning, basic deep learning, like I am not using any libraries like PyTorch or Keras or TensorFlow, those kind of libraries. I am trying to use only NumPy. And if these words mean nothing to you right now, don't worry about it. So there you can use placeholders using none, and then under the using a loop to save numbers. So if you find that if the loop doesn't work correctly, it will remain a none, so none data type. Like, or you can suppose you are doubtful about a particular loop or a particular variable, you can just put it as none and then run the whole run the rest of the program and see whether your answers are correct, what you have expected. Now those are few of the use cases I have used personally. uh, so that's about non data type, and that finishes off our built-in data types, to be honest. So hopefully this video and the part one of this video clears a lot of the built-in data type concepts, and some of the data types are so extensively used, and as Python is an open source community, there are huge number of methods, attributes related to those, uh, quite a few number like list, tuples, list, sets, um, maps like dictionaries. These should have a separate video to show you the versatility of these data types. Actually, it's quite um, astonishing, to be honest, um, the things you can do with these data types and the methods you can call on these data types. It's quite fascinating. So that's about for this video. Please do subscribe to my channel. I make regular videos, at least I try to make regular videos. um, and it's I understand these videos are a little bit long, on the longer side, but it's a video. I have structured these videos so that you get quite nice concepts ingrained while you're studying a programming language, rather than um, uh, tackling head on the project side of a thing. Let's try to take it slow and try to understand the concepts first of a programming language, because Python is a very versatile programming language, although it's mostly used in um, data science. That's why people do use projects as a leading way to use Python, but I believe Python itself, it's a very, very versatile programming language without even using the libraries. So that's about it. Let me know if you want any other videos. If you find videos in my playlist on Python, please do watch them. If you have any doubts, any questions, any other methods I have missed, do write it in the comments down below, and do subscribe and share with your friends, share with your course mates, and I'll see you in the next one, and stay safe.